Good morning, everyone. So, the topic that I will be discussing today is about ideal gas. So, when we say ideal gas, it is one which PV over T constant under all circumstances. So, before we go to the ideal gas equation, what is STP? So, STP is the standard temperature and pressure. So, under pressure, STP this equals to 1 atm or 101.325 kilopascal or 14.7 psi or so on. And then under temperature, it is equal to 273 kelvins, and volume, it is equal to 22.4 liters, and in mole, it is equals to 1 mole. So I have three derived ideal gas equations. The first one is PV/nRT or paborito niya, where the P here is the absolute pressure. When we say absolute pressure, it is the sum of the atmospheric pressure and the gauge pressure. Okay, so the V is the volume, N is the number of moles, or it is equal to small letter m over m, or the mass over the molecular weight. So here is the units in SI and English units. So R here is the universal gas constant, and T is the absolute temperature. So when you say absolute temperature, this is in Kelvin or Rankine. The second one is the PV equals mRT or pavo rito mo, wherein P is the same with the first equation, V is also the volume, M is the mass, R is the ideal gas constant, wherein it is equal to universal gas constant over the molecular weight. And then the T here is also the absolute temperature. So here is the proof why this is just the same with the first equation. So PV and RT. So here, so N is equals to M over M, or mass over molecular weight. So copy here. So this is so if we're going to rewrite, PV is equals to M, so R over M, M is T. So let R is equals to R over M. I mean, small letter r equals to big letter R over M, or the universal gas constant over the molecular weight. So PV is equals to mRT. So they are just the same. So the last derived equation is the mass density is equals to P over RT, wherein P is the mass density, or is also equal to mass over volume. So proof. So here is the proof. So the first problem is an air is kept at a pressure of 200 kilopascal and a temperature of 33 degrees Celsius in a 500 liters container. What is the mass of the air? Okay, so first we are going to identify the given. So we have here a pressure of 200 kilopascal. Temperature is 30 degrees Celsius. So is this an absolute temperature? No. That is why we need to convert the 30 degrees Celsius into an absolute temperature, or into in Kelvin. So we need to add 273 to convert it to Kelvin. So the volume is 500 liters. So what is asked is the mass of the air. So we are going to use the paborito mo equation, or PV equals mRT, wherein the derived ideal gas constant of the air is equal to 0.287 kilojoule per kilogram Kelvin. So direct substitution is 200 kilopascal, and then we need to convert the volume, which is 500 liters, into a cubic meters, because so that we can be able to easily canceling out the units. So 500 liters. So we know that we know that a 1 cubic meters is equals to 1,000 liters. So equals to the required mass. So 0.287, the ideal gas constant, and this is a 30 plus 273 temperature. So this is now an absolute temperature. So if you're going to calculate, so just type in your calculator. Okay, so here, okay, so the answer is 1,149.9 grams, or the answer is the mass of the air is 1.15 kilogram. Second problem is to determine the volume occupied by 4 grams of oxygen gas at STP. Again, as a review, so our STP is here. So our solution is, since our given is 4 grams, which is the mass, so we are going to use an equation in the ideal gas which is involving a mass. So that is the Pavorito mo, or PV equals MRT, wherein the derived ideal gas constant of the oxygen is 0.2598. So it's just a direct substitution. So since at STP, this is 101.325 kilopascal. So why are we going to use a kilopascal instead of using PSI, mercury in millimeter, or in inches? So it's because you're going to inspect. So since here we are involving a kilojoule, and then kilograms, and then in Kelvin, so you are involving, so you are going to use an SI units. So there should be a consistency of units so that you can cancel out the units later. So okay, so we are going to use the kilopascal. So our pressure, the absolute pressure, is 101.325 kilopascal, and then the volume is what is asked. So the mass is 4 grams. So since we are involving kilograms, that is why we are going to convert the 4 gram into kilograms. So it is equal to 0.004 kilogram. And then the ideal gas constant of the oxygen is 0.2598. And then at STP, the temperature is 273 Kelvin. So if you're going to cancel the units, so everything will be cancelled out, and the remaining will be in gram or in kilograms. So if we're going to compute, so here, so just type in this equation in your calculator, and then shift solve. So we have 2.79 or 2.8 times 10 raised to negative 3. Okay, so the answer is, so the volume is 0.028 cubic meter.